Welcome back to Unit 3. In Unit 3, we will basically learn about the DC machines. So, first topic of Unit 3 is DC generator. In DC generator, it works based on the principle of electromagnetic induction and it converts the mechanical energy to the electrical energy. Okay. And this DC generator, actually DC machine is mainly classified into DC generator and DC motor. So first here we will see about the DC generator. So in DC generator it has two main parts. One is the stator or the stationary part. This stator basically provides the magnetic field. And the next part is the rotor or the rotating or the moving part. It basically converts the mechanical energy to the electrical energy. So what I told, this DC generator, it works based on the principle of electromagnetic induction that converts the mechanical energy to the electrical energy. Suppose you have a permanent magnet with these fixed pole pieces, north pole and south pole. Now, if you place a moving conductor inside this permanent magnet, what will happen? As per the Faraday's law of electromagnetic induction, EMF will get induced in this conductor. DC generator exactly follows this principle in the operation. Now we will see the different components of the DC generator. The outermost part of the DC generator, you can see this is number 1, which is called the yoke or frame. This yoke or frame, it is the outermost part of the DC generator. It is usually made up of a solid magnetic material. Okay. And what is its main job? Its main job is to protect the inner parts. It acts as a protecting shield to the inner components. Okay. Next, inside the frame or yoke, we have the stator. Okay. We have the stator, and the stator consists of what? The stator consists of these main field poles. In this diagram we have 4 main field poles. This is one, this is another, this is another, this is another. So here we have shown 4 main field poles which are a part of the stator. And stator, I have already mentioned, it is the stationary part of the DC generator. Okay, and these field poles, they are made up of the silicon steel. Why silicon steel? So that it is having high permeability and low hysteresis loss. What do you mean by high permeability? If a magnetic material is having high permeability, means it will allow large number of magnetic field to pass through it. That means magnetic field lines can easily pass through a high permeability material. Okay, and low hysteresis loss means the electrical energy that is lost as heat, it will be less if the magnetic material is having low hysteresis loss. Then the electrical energy that is getting lost as heat, that will be less when that magnetic material is repeatedly getting magnetized or demagnetized. Okay, now if you notice properly, the bottom part of these field poles, they have the horseshoe like shaped. Okay, and inside this DC generator we have the rotating part. Okay, or the rotor. So if you can carefully notice, in between these horseshoe shaped poles and these rotating part, there is some air gap. Why it is kept horseshoe type shaped? So that uniform magnetic flux distribution is maintained in these air gaps. Okay. Now, what happens? These field poles, they generate the constant or stationary magnetic field. Okay, because we are providing the field windings on these field poles. Now, if DC current passes through the field windings, what will happen? These field poles, they will get magnetized, okay, and they will generate the constant magnetic field. Basically, they work as the permanent magnet, okay, with alternating north pole and the south pole. Now, inside we have the rotating part or the rotor or the armature. What we can see, the outermost part or the periphery of the armature core, we have some slots, okay, and in these slots we have the armature winding. Okay, armature winding is what? It is nothing but a conductor. Okay, now when we place this armature winding or armature conductor, it is rotating, it is continuously rotating. Inside these stationary magnetic field, what will happen? As per the Faraday's law of electromagnetic induction, EMF will get induced in these armature conductors, right? And these armature conductors, they are, so these EMF is getting induced in the armature conductor, okay, and these EMF is alternating in nature. That means an AC EMF will get induced in the armature conductor when it is placed inside the stationary magnetic field or moving stationary magnetic field or constant magnetic field as per the Faraday's law of electromagnetic induction. Okay. Now, inside this rotating armature, we have the main part of the DC generator, which is called the commutator. You can see it is labeled as number 6. This commutator, it acts as a rectifier. The AC EMF or the AC current that is getting induced at the armature winding, that commutator, it will convert that AC current to the DC current. Okay, that is its main job. Okay, now you can see level number 7 is the shaft. The shaft, it rotates. That means the armature is mechanically rotating, and this commutator, it is converting the AC current induced in the armature winding to the DC current. Okay. Now, this commutator, it connects the armature winding or armature conductor to some external circuit through some carbon or graphite brushes. Okay. Now, due to this commutator or this commutator, it will make sure that the external circuit, it gets the DC supply only. So, I repeat once again, the outermost shell of this DC generator is the yoke or the frame. Its main function is to work as a protecting shield. Now, inside the yoke or frame, we have the stator or the stationary part that contains these main field poles, and they are made of the silicon steel. Okay, in order to this silicon steel material is such that it has the high permeability and low hysteresis loss. Now, field windings are there on each of these field poles. Now, when DC current passes through these field windings, these field poles, they will get energized and they will get magnetized. Basically, these field poles, they work as the permanent magnet. Okay, now there is a gap between these field poles and the rotating part of the DC generator. In order to ensure uniform magnetic flux maintained between the field poles and the armature winding, a horseshoe shaped like poles has been created. Now, at the outer edge of the armature core, we have some slots. So, since we have these slots at the outer edge of the armature core, and this armature is continuously rotating, right? And when this rotating armature is placed inside a constant or stationary magnetic field, what will happen? It will cut the it will continuously cut the stationary magnetic field. As a result, as per the law of Faraday's electromagnetic induction, some EMF will get induced in the armature winding, which is alternating in nature. Inside the armature winding, we have the commutator, which is the main part of the DC generator. This commutator, it will work as a rectifier and it will convert that AC current induced in the armature winding to the DC current, and through brushes it will make sure that the DC current reaches to the load. That's all about the working of the DC generator.